Okay, class, here's the case where we're looking at adding rational expressions where one of our denominators or both potentially have to be factored. As we can see in our left rational expression, we have a denominator of x squared minus 9, which is a difference of two perfect squares. So the first thing we want to do before we can find the LCD is to factor our denominators if possible. So we'll rewrite this as 4 over, and x squared minus 9 breaks into x plus 3 and x minus 3. And we'll leave the right rational expression the same. Okay. Now after factoring, we notice that the LCD is the combination of x plus 3 and x minus 3. Okay, so what we want to do is rewrite our expressions with the equivalent expressions with that LCD. However, in the first example, we already have that LCD. So the first example has both factors in the denominator, so we can leave that alone. And as we're working here, think of excluded values. What are those excluded values, William, who should be watching this video? Yes, -3 and 3. Okay, so over here on the right, I need to multiply the top by an x plus 3 because there'll be an x plus 3 in the bottom here. Okay, so now all we need to do here is do some distribution. Okay, so it's going to be 4 plus, I'm going to distribute the 2n, 2x, 2 times 3 is 6, and all over my common denominator of x plus 3 and x minus 3. What do we do next, Brianne? Why, yes, we combine like terms on the top. Very, very good. So this is going to be 2x plus 10 in the top over an x plus 3 and an x minus 3. And now, what do we do here? We always look for what at the end? A GCF, good. So, and we do have a GCF in the top. The only problem with that is once we factor that GCF out, it really doesn't help us with anything. Because I take a 2 out from 2x, I'm left with x. I take a 2 out from 10, and I'm left with a positive 5. And that's all over x plus 3 and x minus 3. There's no common factors here for us to cancel. And then I'm concerned about the excluded values, which Will told us x cannot equal a -3 or a +3.